Welcome, students, to another important topic in cooling tower design. This is interference and recirculation in cooling towers. To begin with, interference refers to elevated well conditions at the tower inlet caused by external heat sources upwind, such as adjacent towers, chillers, or process equipment, rather than by the tower's own discharge air. So, in case of interference, the hot air comes from another source than the tower itself. As you can see, wind carries the hot and saturated air from another source into the inlet of another cooling tower. What are the issues caused by this? At first, it artificially increases the inlet wet bulb temperature, degrading cooling performance. It also exacerbates the risk of system fouling, drift, plume-related visibility issues when combined with wind. What are the remedies? How to remedy the issues? We have to maintain adequate spacing between towers and other heat-emitting equipments or structures to prevent overlapping airstreams. We have to use windbreakers or air guiding louvers if interference persists, so that the inlet is protected from upwind heat plumes. The next issue is, of course, recirculation. Recirculation occurs when warm air, saturated air discharged from a cooling tower is drawn back into its air inlet. So in this case, the warm air comes from the cooling tower itself. This happens when inlet velocities are high enough to create low pressure zones around the intake, while discharge velocities are too low to carry the plume clear of the tower. This can happen in case of a forced drop cooling tower as well as a induced drop cooling tower, but in case of induced drop cooling tower, the issues are a bit less. So what are the issues? It can raise cold water outlet temperature from 1 to 5 degrees centigrade. It reduces heat rejection capacity and may force system operation above design limits or trigger shutdowns. It can worsen drift and plume visibility, leading to fogging or icing hazards nearby. So we can specify the inlet and outlet air velocities. The discharge air exits 10 meters per second and inlet air enters at 3.5 meters per second to stop recirculation. We can orient multi-cell towers so fan discharge aligns with prevailing wind, concentrating plumes or better buoyancy and reduced re-entrainment. And we can raise the support so that the ambient air does not enters the inlet, but the hot air exits.